Hello, good afternoon, ladies and gentlemen. Can everybody hear me? Okay, that's good. Well, we've got 45 minutes to address probably the most compelling situation that in the aerospace industry today, and that's associated with the ability of the global supply chain to match the volume of aircraft that both of the OEMs, Airbus and Boeing, are capable of selling. As far as I'm aware, I've been in this industry a long time, I can't ever remember us being in that situation before. So, and that's of course coupled by the fact, as we've heard during the course of this week, that business these days is shifting away from the traditional markets of Europe and America, and now in excess of 40% of all aircraft are likely to be sold, commercial aircraft are likely to be sold in Asia. And of course those countries want to develop their own industry, and that means that the supply chain is also likely to move. So this pretty big issue we've got, 45 minutes, hopefully we're going to find some solutions to it, and it's again looking back at what's happened in the past and how do we prevent some of the problems that we saw in the past on 787, A350, year, 2 year slips on delivery into service. What do we need to do to make sure that we avoid those pitfalls for the future? To address that, I've got a very, very talented team here with me on the podium, who've got a wide range of experience in all aspects of the supply chain. I added up just a few minutes ago that we've got well over 100 years of experience with the panel. If you put me into that, we've got about 200 years of experience here. So probably what I would like to do, I'd like to sort of start off with, I'd like to probably start off by introducing the team that I've got with me. So David Storch, who's here at the side of me, Chairman, President and CEO of AAR Corp. I've got Badam Apu, who's a Managing Director and CEO of Siant. Michael Tellier from Dassault Systèmes, and Dr. Philip Lewis from Toisan Precision Industries. So a good range of experiences there. So probably starting off with what many people in the room would consider to be one of the major issues that we face today, and that is that that there is a lot of pressure on the OEMs to move production to geographies that are providing their revenue through the procurement of new aircraft orders. When you look at that, how does it actually match what I've just been talking about? How can this support the competitive position in the supply chain? Because you're putting new work into new suppliers in new parts of the world. I think everybody in the room knows that moving work is a really, really big issue. So, Krishna, can you start us off with that, please?
Absolutely, Ross. I think what we have done well and where things have worked for our customers, who are typically either the OEMs or the large tier ones, is the reality is that you have to put work in new geographies. That's what the market demands. That's what the OEMs are required to do in many cases, or there might even be a lot of commercial sense to do it in some cases. But the reality is that work has to move between geographies. Where we see a lot of value, or where we see how this can be made to work, is really, it can't be just a pick and place kind of a model. You just can't take the work that's been going on historically in, say, a Europe or a North America, and then try to replicate the same thing in a different geography. There are a lot of realities of markets in terms of, there are different kinds of materials available, there are different skill sets of people and workforce that is available. And also you have to relook at the engineering design and the engineering process of how the product can be made a little bit differently to take into account the realities of that market. So where we have successfully helped our customers, again the OEMs, is when the product had to move between geographies, where we came in where we sort of relooked at the design, said, is there a better way to redesign the product so it can be manufactured better in this new geography? Is there a better process that can be written to actually be followed to make the manufacturing more efficient? Also, is there a change in technology, be it new materials, new components, new sub-assemblies, what have you, to say that let's take into account the reality of the new geography rather than sort of just pick and place what exists and what's worked for the last 20, 50, whatever number of years.
Okay, so what you're saying is that a lot of your engineering capability, you're developing maturity in the engineering capability that can be flowed down and shorten the learning period where new suppliers can build upon capability. And I guess, Michelle, that's your business. You know, you transformed how we build airplanes today with Dassault systems, moved away from 2D drawings. But tell me, you're very close to both OEMs. And what I'd like to know, what we'd like to know is what are solutions with your systems, with your relationship with the OEMs, that you're doing to help suppliers? What do you see as the key transformations in the process that are currently underway, being envisaged by the OEMs to improve supply chain performance in the future?
Okay, yeah, we've supplied technology to develop the aircraft. Foremost was really moving from drawings and other formats to digital formats and 3D, and that was important in many ways, but certainly to allow the development of collaborative networks. I mean, we used to develop aircraft where we bring everybody together. You brought in your contractors, and you all put everybody in the same facility for a series of months and years. And now we're not doing that anymore. We build these collaborative networks, like for the 87 or the 350, and that allows for a lot more geographic distribution of the work, which wasn't possible before. Yeah. So that first step was creating an environment and a technology where people, we could really distribute work for the first time on a very, very, very large scale. So that was, I'd say, the first thing that we did. And I think the second one is what we're focused on today, which is recognizing that you also have to look at it from the supplier versus the OEM, not just from the OEM versus the supplier. And if you're a supplier, you've got multiple different programs, multiple different OEMs or large tiers that you're supporting. That creates a lot of complexity. So now we've been working mostly with using both standards and different ways of decoupling the work, so that a large supplier can build their entire industrial process, their fabrication, tooling, their quality, regardless of whether they're supporting one OEM's methods or another OEM's methods or another OEM's methods. So they can standardize their methods, their expertise, and then support multiple different programs. And I think that's really the next step in terms of how it works. I mean, I think the first phases was very OEM-centric, making sure you maintain configuration, consistency, quality, even though you're moving work globally. And now I think the phase is making the supply chain much more efficient, because the challenge is getting the supply chain to rate. Yeah. And that's where we are today.
But in spite of all that, in spite of all the systemization and all the fantastic things that we've actually seen, the period of time that it takes for work to be transferred from one supplier to a new supplier, as Krishna was saying, and the constraints that we see from the OEMs in terms of time scales, in making sure that first articles and first part qualification, it's taken as long today, even with all that great technology, as it did some time ago. So what is a company like yours doing to help in improving that situation?
Okay, that's a tough question. I think that from a baseline perspective, what we're developing today in terms of aircraft systems and platforms is much more sophisticated than we were doing in the past. We have new materials, composites, now additive. We have new technologies that are being brought to bear. So that's making it tougher, like you said, to shift work from one supplier to another. And because the technology has got a steeper learning curve than it did in the past. I mean, before, if you were stamping and machining part hydroforming parts versus machining, to today, continuous tape layup and other technologies that you're familiar with, create a whole new different stress on being able to acquire that expertise, move that expertise without interrupting rate or quality. So I would say that it's not an even playing field. We continuously make it more and more challenging. So on the other hand, what we're doing to try to keep up with that increase in challenge, I think, is actually trying to simplify the design of the processes. The closer we can get the engineering tuned to the fabrication process and the context like you talked about, the easier it is to transition. If we pretend the engineering doesn't have to change or is what it is and will not adapt, then I think we make it much more complicated. So I think you have to go back to the design. You have to simplify it for producibility, for cost, and if you will, for multi-sourcing.
Yeah, I guess that's the key to it.
Yeah.
Very much about it making it much more of a
Simple, yeah.
simple process, simpler.
Yeah. And we develop technologies to pretty much automate a lot of that today. So.
David, I'll come back to you in a minute because you're in a slightly different part of the market than the other three gentlemen. But Philip, I mean, you're here in the UAE. Had the experience that you've had. You probably benefited a lot from offset, and you're seeing sort of a lot of the changes. But what I'd like to ask you is this: that we know that both OEMs have suffered significant supply chain failures, particularly on commercial aircraft in recent years, and that has caused costs. It's caused huge disappointment to the airlines, and I guess to the travelling population as a whole. Some doubt about whether the aerospace industry actually can do the sort of things that it keeps promising that it could do. What I'd like to know from you, from what you've seen in your experience, what do you think, looking forward, are the things that we ought to do globally in the supply chain to make sure that these delays don't impact in the future?
So I think the starting point is to probably recognise that what's been going on in terms of the OEMs focusing more on systems engineering, assembly, the design, and outsourcing modules and so on. It's probably going to continue. Maybe there might be a slight rebalancing with some of the lessons that have been learned, but inevitably I think that's still going to be the way forward. And if that is the case, then you need to think a bit about the supply chain support and how it might need to be remodeled. And so I think that still means that there'll inevitably further consolidation to build scale, to build capability, because again, one of the problems that you allude to is that the smaller suppliers have often had less capability. I mean, it's not exclusively the smaller suppliers. I mean, I think there's well-documented instances of some of the larger suppliers not performing. But nonetheless, I think that trend towards consolidation, perhaps more vertical integration as well, which we've already seen with mergers and acquisitions type activity. So I think there'll inevitably be some continued structural changes in the industry that will have to happen to ensure that that capability is there. I also think that there's probably going to be more has to be done at the operational level. So, for example, in the point of Airbus, we've had the introduction of GRAMS, probably back with A380, so 15 years ago, which has been progressively improved to help this situation, but it still needs to go. There needs to be deeper reach into the supply chain. If you're depending more and more on supply chain, the reach into the supply chain needs to be deeper on that side of things. So I think from an operational point of view, and it's easy things to say like supplier risk management, but how does that get improved? Further looking at the financial risk, because a lot of this in the past has been about their ability to sustain the ramp up in working capital, for example, that's required with some of these ramp ups. So that sort of analysis, I think, will have to be taken to another level. So I think you've got structural stuff and operational stuff, I think the bottom line comes down to this in this industry, it's all about picking the right partners, okay? Not just suppliers, but the right partners in this, whether it's Dassault Systems or any other partner in that process.
But does that mean more consolidation?
Sorry?
Does that mean more consolidation?
I almost think it's inevitable. Of course, interestingly, you talk a bit about the need or the desire to reorientate some of the supply chain around emerging economies and the need for industrial cooperation and offset. So there's a bit of a tension there between the two, because you're bringing new entrants, bringing new capacity and so on and so forth, as well as the need to build scale, which is where the consolidation comes in. But I think the thing that can link those two together is all about the partnerships and how those partnerships are put together, whether it's JV, whether they're contractual type partnerships, whatever. But I think it's all going to be around that how you balance that tension between the two.
And do you think that, again, from your own experience, that new entrants, like your own company, the way that Krishna was talking before, do you think that they add efficiencies over the legacy type companies? So bad practice doesn't come with them.
So the advantage we have certainly is we don't have the legacy. So we don't have, and the legacy in a couple of ways. We don't have legacy in terms of equipment. So many places where I worked before, you've got 10, 20-year-old machine tools. Now there's an advantage to that in some ways in terms of depreciation, but there's also a big disadvantage on it. So new entrants go straight to the latest technology on that side. And I think that is a big advantage. Similarly, not just in technology, but also in the working practices, the opportunity to establish effectively greenfield site on this and establish the right working environment, the right culture, the right systems, the right structures in place from day one, as opposed to having to re-engineer them on that. So I think we do have those advantages. On the other hand, as a new entrant, you have some significant disadvantages. I mean, the one thing in this business is the DNA that's in the people around this business for many years is pretty fundamental, because despite everything, despite what we say, we all know everything is not quite as well documented as it ought to be and should be. So I mean, because if it was, we wouldn't need to do things like last article inspections, for example, because we know that what we're making would be the same as the drawing, which isn't always the case.
No. Well, I think that many people in the audience would be able to relate to that.
Unfortunately.
David, you're in a fascinating, different part of the industry. Certainly part of the industry that I know little about. I mean, your job is very much sourcing and supporting airlines with aftermarket. And what must be very difficult for airlines, and indeed for the military, is what are the real advantages of civil airlines or defence organisations outsourcing their aftermarket supply chain to your company?
That's a great question. Let me start by just giving some historical perspective, if I may. You mentioned that we have 100 years of experience between us, and I have 38 of those 100 years, so I've been around a little bit, and I've seen the industry really go through many transformations. So when I go back to my early days in this industry, the giants in the airline industry were folks like with the names of Pan Am, Eastern, TWA, and many of these guys don't exist over in England. You had British Caledonian, and over time, this world has changed. And the world has changed largely because of competitive factors, and the competitiveness has caused airlines to look at their operations very differently. So when you look at the tension inside an airline, you have tension between the marketing folks who want to make sure that an airplane never misses its departure time due to a missing part. You have the maintenance folks who want to maintain control over the entire process. And you have the financing guys who are looking at how we stay in business. And so if you look over time, the control was largely in the maintenance department's hands. And then over time, that's shifted to the finance guys. The advantages for the airlines to outsource their supply chain is around capital, it's around obsolescence, it's around dependability and reliability, so dispatch reliability, and essentially focus. So when we go into an airline and we take on their supply chain, we relieve them of their capital investment, we relieve them of the obsolescence factor that goes with the ownership of the spares, and then we relieve them of the operational burden, which includes people as well as facilities and all those things that go around supporting that. And the value proposition becomes quite compelling when the airline studies it closely. In terms of militaries, the militaries are finding themselves in similar positions. So if you look back in time, for instance, in the U.S. government had a bottomless supply of money. Well, that's no longer the case. And therefore, they have to look at the pressing issues of keeping their fleet serviceable while doing it within a budget constraint. And so therefore, they're looking at commercial best practices to figure out how to go ahead and be more efficient. I'll give you one example of a success story we have, and that is actually not supporting the U.S. government, but supporting the British government. So the British government has a fleet of 7 AWACS airplanes, and they're considered a national treasure in Great Britain. They were operating, before we entered the picture, they were operating 3 of the aircraft as opposed to against their goal of 6 aircraft. And the reason they were only operating 3 aircraft is they couldn't manage the supply chain to keep the fleet flying. So we came in the picture, and we focused on forecasting and making sure we had the right parts. And today they operate 6 aircraft, which is their goal. And they couldn't do it without a third party coming in and taking a look at how they were functioning and using commercial best practices to make it work. So as governments look to expand their fleets and look to keep their fleets flying and no longer have boundless, let's say, capital availability, they look to get more efficient as well. It creates opportunities for folks to come in and offer a solution.
But, I mean, sourcing from the supply chain for aftermarket must be a nightmare, because if you go to Philip and you ask him to produce legacy parts, low quantity, he's not interested. And probably he's got a business that's using all of Michelle's tools. You know, everybody's geared up on 3D drawings and things like that. Probably don't know how to read a 2D drawing. I mean, it must be a nightmare.
Yeah, so we have 60 years experience in this regard. So we have a pretty good historical reference point. So we understand how to source. So that's a core competency of our company.
You must carry inventory.
We carry 400 million of inventory. So yeah, we carry a significant book of inventory to support the fleet that we support, correct.
So carrying inventory, presumably you'll be on liquidating damages for lack of performance, because you trade on performance.
Right. Yeah, dispatch reliability is critical to our value proposition. So the customer wants to know he's going to have the right part at the right place at the right time, whether it be a military user or a commercial user.
Okay, so though, what are the risks then? What are the things that you wake up at 2 o'clock in the morning worrying about?
Yeah, there are other things I worry about at 2 o'clock in the morning, but the things I think about that are important to the company and are important to our customer is making sure that we deliver against our commitments and make sure that we give the dispatch reliability that the customer is in fact looking for. And making sure, I have to make sure, we have 6,000 people around the world. I have to make sure that our people are all in tune with what the customers are demanding and make sure that we deliver. Because our reputation is the most important thing to the company. So unlike the OEMs, we don't have a captive audience. We have to earn our stripes every day. So I don't control the technology. What I control is the customer, my performance that leads to improving the customer's performance. So I have to make sure that my team gets it and is connected to the value proposition to make sure that the customer's fleet is flying on a predictable, regular basis, and I can do it in a way that saves the customer money.
Do you have any predictability in aircraft, legacy aircraft, where there is potential failure to take place so that you can react?
Absolutely. So if you look at the history of our business in our industry, we based many of our decisions in the past on past performance and history. Today, the analytics is such, the predictive analytics is such, that we can go ahead and forecast the future, and with a much better percentage of reliability than we were ever able to do. Because in the past, we were only based on the past. Now we have some pretty nifty computer capability, software capability that allows us to forecast the future based on the knowledge, all the knowledge that we have from the past. So they call it, big data is the new name for what we're referring to, but it's very important in our business that you invest. I mean, one of our, I think, competitive advantages is we've invested in data collection and data disposal.
Very good. Very interesting part of the business. And probably not unrelated, Krishna, to you, that historically, companies, big companies, and indeed to a certain extent small companies, saw keeping their own design engineering, their own engineering services as the crown jewels. What case would you make for outsourcing? How is it enhancing global supply chain?
That's a good question, because if you look at it, the moment we say engineering or R&D or technology, that becomes the crown jewels of many of our clients and the companies that we're working with. But if you really sort of peel the onion a little bit and look at, in any product, what is the real core technology? Right? What is the differentiating technology? It's typically what we see as 20%, 30% of the product. The other, at least from a volume from a volume perspective, right? From a value perspective, obviously it's disproportionately higher because that's the core of the product and that drives the product. So where we come in, or companies like us come in, is really doing that 70 or 80%. We might not necessarily do the core engineering or the core technology. Say in the aerospace industry, for example, materials ends up being a lot of times the core technology. It's something a company wants to protect. In many cases, it might even be protected by the government and so on and so forth. So while OEMs and large tier ones keep that 30, 40, 20, whatever percentage, the real volume comes in detailing out the product, doing this morning, I think the gentleman from Virgin talked about things like computational fluid dynamics and proving out the product and doing the physical tests and correlating them with the digital tests. So there is a significant amount around the core technology that has to happen before a product actually can be certified and then tested and then go into production. So what we work very well is we come in that 70%, because that 70% also trends to be a lot of times the variability, the surge capacity, what have you, because the core research might go on in an organization over a period of time, but really when they're trying to bring a product to life commercializing that technology is where we come in and really provide the flexibility and the capacity.
So Michelle has been a godsend to you, I guess.
Absolutely.
Giving you the systems to do all that.
Of course.
And this week, or these last day or so, clear recognition in this summit that aerospace industry is clearly a global industry, and that the only really way to survive in this industry and prosper is through collaboration. So what do you see, Michelle, as seen as the 2 or 3 really core challenges that's facing the industry geographically, of what needs to be done where you've got disparate companies in different parts of the world with different cultures, different languages, different behaviors. What are we going to do?
Yeah, I'll talk about an example where we tried to do this and we succeeded in large part. On the 8.7, you know, we set up a global collaborative environment which allowed all the partners to collaborate on that program. We had, I think, in the end it was over 65 different companies, 120 sites, 26 languages, 8,500 engineers, collaborating simultaneously on the same product definition. So that's the context in which these large programs occur. And you know, the language part alone is extremely challenging. And, you know, ironically, we like to say that, you know, bringing everything into 3D or making everything digital kind of creates a common language, because now the product is the language, and you're not articulating around what's written, it's what's actually defined, and it changes that. But you know, at the end of the day, it is about collaboration. Effectively, efficiently developing an aircraft or a sophisticated system like an aircraft, you know, depends on all these engineers working together. Increasingly, you know, to go back to your earlier point, it's not just about developing an aircraft that will perform, it's also about developing an aircraft that can be fabricated, that can be sourced, that can be assembled efficiently. And that is where we really see the new trend coming in, is not just collaboration, if you will, horizontally across the different systems, but also collaboration vertically up and down the different disciplines. So we're in a world now where we have engineering, fabrication, inspection, test actually being parsed out, some of it being multi-sourced, and that being done with the same sort of geographic and cultural diversity that we saw, for instance, on the 8.7 and again on the 350. And yeah, I mean, you know, the technology that we've been developing for that is these collaborative platforms, using big data technology, using internet technology, and to try to make all that happen. And then, you know, you have to overlay that with export control conditions, ITAR conditions, and, you know, also the IP protection of one partner versus another. So you know, that's the context, and today we're successfully deploying solutions that can parse that out. But, you know, we think that you know, if we don't develop that, we're going to put a brake on the ability of the aerospace industry to diversify and distribute work to create the maximum value. And that, for us, is collaboration.
I'd like to come to the audience shortly and just see if there's any questions out there that you want to put to the panel. But perhaps while you're thinking about that, David, Philip, just for you, demand for aircraft, and indeed with the now sort of return to spending in defence, but looking at the commercial demand, you know, the commercial demand of single-aisle aircraft, Boeing, Airbus, 60 a month, maybe any day soon, wide body, 10, 15, I don't know, maybe 3,000 aircraft a year. Are we approaching a situation where there's going to have to be shared production around the world? You know, are we seeing a situation where people may already have these packages of work, but simply cannot afford to make the investment to meet these demands?
I think that's absolutely true. If you look at the whole thing about the globalization of production, and people often talk about just low-cost production, which may or may not be true, and it often doesn't deliver the benefits that people thought, although I think some of that might be about the process which is adopted for the movement of production, and should just be more of a recognition that, you know, it probably isn't a one-year project for sophisticated movement of products. It's a 3 or 5 year type project followed by a bit of a ramp up, and you know, I think people have learned over time it's going to take longer to do than it might do. So yes, people talk about low cost, but inevitably, as you say, with the large increase in build rate, the traditional suppliers looking for other ways to increase their capacity, and people who've got capital, the willingness to invest, I think is clear. I mean, you know, my company is a good example of that. Has added additional capacity to both the single aisle rate and long range rate. So I think that's extremely true. I think again, I go back to the point I made earlier about the need to get the partnerships right. I mean, making those changes can take a long time. If you get the partnerships right, and the relationships between, again, companies like TPI and the tier 1s and tier 2s, where they're supporting each other for a win-win type situation on that, then I think that's more likely to be done more quickly and more profitably than just moving a package of work in the way that might have happened 10 years ago, let's say. And might happen now occasionally, but I think people have learned the lessons from the past.
I agree with that. Can I turn to the audience? Is there any questions from anybody that you'd like to put to the panel? Gentleman here.
My name is hello. My name is Asar Mukherjee. I'm from India. Thank you for a wonderful discussion on the supply chain. My question or your thoughts on, you have talked about the consolidation of capacities and working together, creating these kind of capacities where you don't have abilities to invest. Can we also think of, consolidation of buying? Or what are the thoughts that the panel has in mind on consolidation of buying? So that, like I'll give an example of like pre-preg material for the entire Southeast Asia. We do not have any buying of that in composite manufacturing. So can we do something, or what are the thoughts that the elite panel has on that?
Okay, who'd like to pick that up?
So, for at least talk about the bit of the industry I'm in, which is more metal. I mean, clearly both Airbus and Boeing have made steps forwards on that. Airbus in the sense of Conbid, where they aggregate all their aluminium demands and titanium demands globally and try and allocate across the mills. I mean, it's a complicated process that has its own pitfalls, but it's relatively successful. So certainly there's a model for what you're suggesting in composites. There's certainly a model in the raw material on the metal side, for sure there is. And it's been developing over a number of years, and it's reflected through into the commercial agreements that suppliers have with the OEM. So I think there is a model there. How much further it can go in composites, I'm not sure, but for sure.
Content?
I have another example. Very different, nothing to do with material, but recently we deployed a collaborative platform for Europe, in particular in France. So all of the sub-tier suppliers, instead of having to procure independently all their own solutions, have one specific collaborative platform that the OEMs drop work into. And that way, at least from a computing, IT, and technology standpoint, it's a mutualized capability. So it takes a lot of the individual, if you will, risk, cost, complexity, and it democratizes, if you will, a lot of the technology across the lower sub-tiers.
Content? Did I see a question over here? No? Okay, so to a large extent, your business, David, is very much dependent upon the way that products are engineered today and manufactured today. So if you were looking at the three people to your left who are producing the products that you will be sourcing for the future, what would you ask of them?
So our business is based on the number of aircraft that are in the system.
Yep.
So the more aircraft that the supply chain can produce, the better off it is for us. Do your thing and we'll all be happy.
So, just as we come towards the end of our period, what I'd like to ask each of you, because we started off by saying, how do we prevent the problems of the past? What do you predict, each one of you, what would you see as being changes that we can expect to see in the next 5 to 10 years that are going to make a significant transformation in the efficiency of the global aerospace supply chain? Start with you. I'll work that way.
Okay, so I think if we accept that the globalization of the industry is going to continue, I mean, I think that's inevitable. I think one of the key changes will have to be the smoother interoperability of the elements of the supply chain. There's going to be more of a distributed supply chain, more globalized, so it'll have to become more interoperable. That will require the use of more analytics throughout the supply chain, deeper reach of the analytics into the supply chain. The phrase used earlier, the leveraging of the big data throughout the supply chain, not just in terms of, in that case, the aftermarket, but in this time, of through the tiers to more quickly identify and predict risks in the supply chain rather than just react to it. So I think this whole interoperability type argument will come more and more to the fore in the globalized supply chain.
So more predictability.
Yeah, well, yeah, but the interoperability
Okay.
will need to improve, and the technology to enable that will have to be deployed. I think it's inevitable that will be a requirement.
And what will be the driver for that? Will that be cost or capacity?
I actually think it will be to make it will be about the operational execution on that, because from the point of view of needing to have a distributed global supply chain to manage risks, to reduce costs, again will be inevitable, but it has to be managed effectively at the execution for the delivery, and I just think that whole interoperability will become more and more important.
Okay, Michelle, next generation of Innovia, I guess.
No. I think sticking to what we do, I think we're going to see a disaggregation of work. I think as we become more efficient, moving the cloud platforms to cloud-based environments, more open environments, and the trend we see generally professionally, which is that there is expertise globally available at all different levels.
Yep.
And instead of it being contracted in large blocks and large work packages, I think we're going to see a significant disaggregation of how work is allocated and executed based on available skills, not based on historical contracts. And I think that can happen at a very granular level, and I think that's going to bring a major impact to the net scalability of the industry, which is really what we're being stressed on today. And I think going back to the aftermarket, if I may, and following up what Bernard said yesterday, yeah, I think certainly additive manufacturing with 3D printing gives an opportunity to shift the ability to fabricate at least non-primary parts and components to the source of need, instead of, in fact, storing them and inventorying them and stocking them. You can, I think we will see the advent of printable capability, distributed.
So for the record, I don't contribute very much to the 100 years of cumulative experience, so you can discount what I say a little bit. But what I see is just, on one side you hear a lot of sort of the buzzwords around technology, be it Internet of Things or big data or so on and so forth. But there's a lot of that in very subtle ways becoming quite applicable to the aerospace industry, be it the amount of data that an aircraft generates and how the data is being analyzed at a real time. You might not see the effects of that because it's not necessarily customer facing, but I think there's a significant amount of new things and innovation that's going on really on how the aircrafts are being built, operated, maintained, and so on and so forth. So I think we will see a lot more of the application of some of these emerging technologies in the aerospace industry going forward.
And David, last word.
Yeah, so we've gone past our time, so I'll make my comments very brief. And I think the biggest question in terms of what faces all of us in the next 5 years, over the next 5-year period, which I think is your question, is how we survive the U.S. presidential race. I'll leave it at that.
Yeah, that's right.
That depends on how you vote.
Okay. Well, what I'd like you to do is well, first of all, thank you to Mubadala for arranging this event. I think it's been extremely stimulating this last 2 days, and it's a unique forum, and I hope we continue to do it. I'd also like to thank the panel. I'd like you to help me thank the panel in the traditional way. Thank you.